We're going to use a very simple business example in this video clip to describe how to derive the basic cost volume profit formulas that we use throughout the examples in this chapter. I'm also going to introduce you to some common abbreviations that I use in my examples and also in the OWL problems. So I think you'll find those very useful. The story here is all about banana cream pies. You're going to be baking these banana cream pies at home, and you want to sell and distribute them over the internet to save costs. So you've hired your best friend Buzz, and Buzz is going to set up this website for you, and you're going to pay Buzz $150 a month, plus you've agreed to pay Buzz some amount based on volume. So you're also going to pay him $1.50 per pie that you sell, because his workload will be larger as you sell more pies. In addition to what you're going to pay Buzz, there are of course some costs involved in producing those pies. So here are the costs that we have. We've got the ingredients for the banana cream pie. We're going to have to box them up. There'll be some shipping involved. It's going to cost $2.50 per pie to ship them to customers. And you're going to be working out of your home kitchen, but you're going to need some specialized equipment, and you'll be able to rent that equipment for $300 a month. Your expectation is, based on what you've seen in the surrounding area, you think that because you make the world's best banana cream pies, you should be able to sell them for $12 each. So the story here is that you know you do one thing really well in your life. You make great banana cream pies. You're not sure how you're going to do as a business person, but you'd really like your business to be a success. So hopefully one of the first questions that you're asking yourself is this one down here. You know, based on the cost structure that we have up here, we have some variable costs, we have some fixed costs, and we have a mixed cost. Based on the cost structure that we see, you should be asking yourself, how many pies would I have to sell each month just to break even? In other words, how much volume would this business have to generate to cover all of its costs? And if you would have to sell so many pies to cover your costs that the amount you need to sell is higher than your expected demand, then something's going to have to change. You either need to be able to reduce your costs, up the selling price of the pies, or reconsider going into business at all. So CVP analysis, cost volume profit analysis, is very basic. It's all about understanding cost structures and how they relate to the volume of a business, and it's really important. It's actually fairly intuitive, but it's really important to many business decisions. We're going to be using the numbers in this example to do basic break-even style and targeted net income analysis for CVP, and also I'll use some of the terminology just to illustrate how to derive those basic equations. Before we do that, let's take a look at the cost structure again. Let's label each one of these costs according to behavior. You learned all about cost behavior in previous chapters. Anywhere we have a cost per pie, that's a good indicator that those are variable costs. So ingredients, boxes, and shipping all appear to be pure variable costs. What about the equipment rental? Well, that's fixed. It's going to cost $300 per month to rent the equipment regardless of how many banana cream pies we produce and sell. There was one other cost up here, the internet services from your friend Buzz. Your internet services are going to cost you $150 per month plus $1.50 per pie. Well, that's a classic example of a mixed cost. Here, we don't have to do any disaggregation to split up the mixed cost. The relative portions of fixed and variable costs are stated contractually in this case. But the website costs are a mixed cost. We have $150 of fixed costs and a $1.50 per pie additional variable cost. Now we're ready to define some terms and basically define some abbreviations that I'll use. So throughout this chapter and in the OWL problems, etc., I'll be using these abbreviations. Q is going to stand for quantity, and to relate this back to the banana cream pie example, we're first going to look at our banana cream pie example, assuming that the expectation you have is that you can sell 500 pies per month. So in that case, Q would be 500 pies. One of the assumptions of break-even analysis, one of the assumptions of CVP analysis, I should say more generically, and you'll see all of these in your textbook, is that quantity sold equals quantity produced. We don't have inventory carryovers from period to period. So our assumption is going to be that we produce and sell 500 banana cream pies. USP is short for unit selling price. The banana cream pies each sell for $12. UVC is unit variable cost. For our banana cream pie, the per unit variable cost would be, let's see if I can remember what these are. $1.50 was the internet charge, what we pay our friend Buzz. $4 I think was ingredients, $1 was for the box, and $2.50 was shipping. If you add all of those up, the variable cost per pie, $9. UCM stands for unit contribution margin. The unit contribution margin is the per unit selling price minus the per unit variable cost. So $12 minus $9, or $3. Unit contribution margin is a very important term for us. Unit contribution margin, or in this case $3 per pie, is the amount by which net income will change for each additional pie gets sold. FC stands for fixed costs. We had $300 of equipment rental plus the $150 that we pay Buzz. Total fixed costs $450. NI, net income. We're going to use R to stand for sales revenue. You can compute sales revenue as quantity of pies sold times the selling price apiece. VC would be variable costs, total variable costs. VC is quantity sold times the per unit variable cost. And CM is contribution margin. Contribution margin, here we're talking about total on an income statement. So contribution margin could be defined as revenues minus variable costs, R minus VC, or it would also be the per unit contribution margin times quantity sold, UCM times Q. There's a couple of ratios that will come in handy as well. Contribution margin ratio is CMR. Contribution margin ratio is simply the contribution margin divided by revenue. Okay, so if you're looking at an income statement, it's the contribution margin divided by sales revenue. You can also compute the contribution margin ratio on a per unit basis. It would be the unit contribution margin divided by the unit selling price. And you should get the same answer with either style of computation. VCR stands for variable cost ratio. It's variable cost as a percentage of sales revenue. So variable cost divided by revenue, or per unit variable cost divided by per unit selling price. Because of the way we've defined these terms, the contribution margin ratio and the variable cost ratio must always add up to 1. If 30% of your sales revenue is contribution margin, then 70% of your sales revenue must be variable costs. It works that way. All right, now just to clarify how all of those terms, what they mean and how they're interrelated, let's actually prepare an income statement for the Banana Cream Company using Q as 500 pies sold. And let's actually build the income statement so that you can very clearly see what those terms mean. This is going to seem very obvious, I think, to many of you, but it's really critically important, and the ability to build an income statement with per unit costs and fixed costs is really important to understanding this entire chapter. Also, whenever you solve most types of problems in CVP using one of the formulas or other approaches, the best way to check your answer is to go back in and prove it by building a little income statement just like this. So it looks very obvious, but it's actually very important. Let's start with revenue. What would sales revenue be if they sold 500 pies? Well, each pie sells for $12. So if you take the unit selling price times quantity, you get total revenue of $6,000. Compute variable costs the same way. Per unit variable cost we computed to be $9. $9 times 500 pies is total variable cost of $4,500. Contribution margin, we learned this definition earlier. It's just sales revenue minus all variable costs. Note that variable costs include product variable costs and period costs. So all variable costs get deducted when you go from revenue to contribution margin. In this case, we can compute the contribution margin most simply by simply taking 6,000 minus 4,500. That's the R minus the VC. You could also compute it by taking the per unit contribution margin of $3 a pie times 500 pies. From there, we just need to subtract fixed costs and we can arrive at net income. Fixed costs were $450. Contribution margin minus fixed costs leaves us with net income of $1,050. In our examples, we're going to assume a zero tax rate, but it's actually very easy to adjust CVP analysis for some assumed tax rate. Two more definitions. Could you compute the contribution margin ratio and the variable cost ratio for the banana cream pie example? If you did the math, the answer would be contribution margin ratio of 25%, variable cost ratio of 75%. Notice I could come up with these two different ways. Contribution margin ratio, working from the total income statement, is simply contribution margin of $1,500 divided by sales revenue of $6,000. Or I could do it on a per unit basis. So without any knowledge of Q, I could always take $3 and divide it by $12. You'll get the same answer. Variable cost ratio would either be variable cost divided by revenue or 1 minus the contribution margin ratio. Now spend just a minute thinking about what of these numbers will change when Q changes. When Q changes, revenue and variable costs will obviously change along with it because those are per unit computations. Fixed costs will stay the same. In addition, if all you change is Q, the contribution margin ratio and the variable cost ratio will remain steady. Take a minute and prove that. Pause this, and while it's paused, build an income statement just like we did, where Q equals 1,000. Should look like this when you're done. If you did everything correctly, you should end up with net income of $2,550. We doubled our quantity. Notice that that also resulted in doubling the contribution margin. The contribution margin ratio and variable cost ratios remain constant. Okay, well hopefully now you have a visual, a picture of the income statement and the relationships between those items. Let's build on those relationships and actually derive the formulas for cost volume profit analysis. It's all based on the income statement. So here it is. I just highlighted this line, and it really is nothing more than an income statement. Very, very basic. Sales minus variable expenses minus fixed expenses equals net income. Okay, so it's identical to what we just built for the banana cream pie example. The only difference is I'm now, spreading it out horizontally instead of vertically. Let's translate that to a formula format using the abbreviations I showed you earlier. Revenues minus variable costs minus fixed costs equals net income. Same thing, right? That's just an income statement. Now, all we're going to do is replace some of these things and do some algebra to move them around, and we'll end up with a very useful formula for break-even analysis. The first thing I'm doing is just replacing revenue and variable costs with the term that includes Q. So as we saw earlier, revenue is simply unit selling price times quantity sold. Total variable cost is simply per unit variable cost times quantity sold. So we're going to replace R with this phrase and variable cost with that phrase, and we've still got the same basic statement of net income. Now, I've just done a little bit of algebra, and I've restated these two terms. I've removed the Q, and I can restate this algebraically as unit selling price minus unit variable cost times Q. Finish out the formula. Now, what's unit selling price minus unit variable cost? Well, we know that is unit contribution margin. That's the next replacement. So now we have unit contribution margin times Q minus fixed costs equals net income. Next step is to just do some simple algebra, and I'm going to remove fixed costs from the left-hand side and add it to the right-hand side of the equation. So I'm basically adding fixed costs to both sides of the equation. It disappears from the left, and now I have this formula. And that basically gets us there. From here, all I do is divide both sides of this by unit contribution margin. So that leaves me with quantity, Q, equals net income plus fixed costs divided by unit contribution margin. I've taken this and divided both sides by unit contribution margin. And this is basically one of the most useful formulas for doing break-even analysis and any targeted profit type of analysis as well. Basically, in words, what this formula does for you is it computes Q, quantity, where Q is, in our case, the number of banana cream pies that you would need to sell to get to any targeted level of net income or profits. When net income is a 0, then we would call this a break-even formula. Break-even formula would just say Q equals fixed costs divided by unit contribution margin, because in break-even, net income is 0. This formula is multi-purpose. It does both break-even and any targeted level of net income type questions. We'll use this formula shortly to find out how many banana cream pies you'd actually have to sell to break even or achieve some level of profits. But before we do that, let's derive another useful formula, and we're going to really start from the same place. We're going to start from, once again, a horizontal statement of just the income statement, and we're going to come up with another formula where instead of solving for Q, how many units do we have to sell to break even, we'll solve for sales dollars. How high does revenue, R, have to be before we can break even? So just another way of looking at volume. Instead of looking at volume in terms of units, we're going to look at volume in terms of sales dollars or revenue. It's going to work the same way. We're just going to plug some terms that we know. We're going to replace some of these terms and then rearrange things. The first step is just to replace revenue minus variable costs with contribution margin. Contribution margin can be defined as revenue times the contribution margin ratio. So we're going to replace contribution margin with revenue times contribution margin ratio. So we end up with this formula. Then, similar to what I did previously, I just add fixed costs to both sides. And finally, I just divide both sides algebraically by the contribution margin ratio. And now I have sales revenue all by itself on the left. And this is the formula that you can use instead of the Q formula when what you're looking for is what level of sales revenue is needed to generate any desired profit for a company. Notice we're solving for R and dividing by the contribution margin ratio. In the other formula, we were solving for Q and dividing by the unit contribution margin. We'll demonstrate this one for the banana cream pie example as well.